Hello, everyone. We're back with another session, another interesting session, I have to say. For the first time, we're going to really talk about a specific book. It's a book about machine learning, written by Hariom Tatsat, present. I'll let him introduce himself, and we'll talk about, machine learning has been around since the 60s. There's been lots of books written about machine learning. I like the book because it seems to be based on case studies. So let's see. I'm a big believer in practical application. So we'll talk a little bit about the language, machine learning, deep learning, reinforcement learning, all these AI discussions. Then we'll talk about the advantages and disadvantages of machine learning. And then we'll talk about specific topics. So let's not waste any more time. Hariom, tell us a little bit about yourself and why you wrote this book.
Thank you very much, Patrick. That was really kind introduction. So, and first and foremost thing, I'd like to thank you for the work that you are doing with the podcast and all. I go through the podcast and it's really amazing. So talking about me, I have around 10 plus years of experience working as a quant. And currently I'm working for an investment bank in New York. So I like to talk about things in kind of technical terms. So I divide my overall career in like two regimes. So the first regime was the first 4 to 5 years of my career where I worked as a conventional quant, normal derivative pricing. And I think I can be slightly more technical on this podcast. So what I was working on was like stochastic calculus, Monte Carlo simulation, market risk, counterparty credit risk, all this kind of stuff. Then came the second stage, or the second regime, I call it, where I'm working currently on predictive models and basically using data-driven models, using statistics, little bit of data science. And that is where I became interested in writing this book. So coming to the why part of this book, you already described this book. So this book is called Blueprints for Data Science and Machine Learning in Finance. So coming to the why of this book, I divide that why into three reasons. So the first reason being the timing. So if you think about the current state of machine learning and data science in finance, there are a lot of use cases currently. So be it trading or portfolio management, we have seen quite a lot of use cases. And with more data, with faster computers, with GPU, it's going to grow going forward. So we felt that the time is ripe to go ahead and write a book related to machine learning and data science in finance. So that was reason number one. And that was kind of a high level reason. Reason two is when we looked into the literature which is currently available related to machine learning, especially in finance. Of course, there are a lot of books, as you mentioned. The books have been written since 1960 onwards. But there were few gaps which we found out in the book, especially when you think about finance. And of course, I'm not saying that there are not many good books. There are, of course, many good books, and we can't even compare our book to those books. They are so good. But the gaps were mostly around the fact that most of the books are concentrated or focused on trading strategies. But the application of machine learning and data science in finance is huge. There are a lot of use cases. So we wanted to focus on other use cases as well. And if you go online or if you go to the internet and start searching for materials, there are a lot of materials available. You get lost. So we wanted to accumulate everything in one book. And that is the gap we wanted to fill in terms of having some kind of detailed book, which is comprehensive and covers quite a lot of case studies. It doesn't only cover the trading strategies, but also a lot of other use cases. And it kind of bridges the gap between the theory part of the machine learning and the practical side of machine learning. So that was the second reason. The third reason is slightly philosophical. So for anything that you do in life, you basically have a philosophy or a reason. And for me, personally, it was giving back to finance fraternity. Meaning that I've spent around like 10 years working as a quant, learned quite a lot of things from people. And I felt that it's the time to give back to people, to help people reinvent their career, because there is this machine learning paradigm shift happening, help students maybe prepare for their interviews, and maybe in a way help in the democratization of machine learning and data science in finance. So that's basically about me and about why of the book.
I mean, and I think it's a great strategy because I've seen lots of machine learning books, and they tend to be very academic in nature. And you're right, there is a new paradigm now. I mean, yes, it's been around for a while, but data hasn't, right? Data now is just everywhere, more and more. And that wasn't the case before. I mean, I think all the data has been created over the past, I think, 3 or 4 years. So you can imagine. Um,
Yeah.
okay, so from a strategic point of view, definitely. And I know that when students go for interviews, they always ask them, what have you done? What have you done with it? I took the class is one thing, but the course, but what did you do? And I think your cases are quite interesting because you tell them exactly how you could use so let's talk about machine learning. Maybe you could give us a little bit of a primer because you're going to be using those terms, and we got people that are familiar with it. Maybe not all students are interested, or maybe all practitioners might not be totally comfortable with it. So maybe machine learning, deep learning, reinforcement learning, AI altogether. Could you give us a bit of a primer
Yeah,
to what I'm
sure.
referring to?
Sure. I mean, there are a lot of terms which are being used interchangeably: AI, machine learning, deep learning, data science, reinforcement learning. And people at times get confused that what are these? And they at times think of AI as deep learning and AI as machine learning. Those are true. But just to summarize what is basically all these AI, machine learning, deep learning. So AI is the superset. You can think of it like maths. So maths is a subject, AI is a subject, right? Then there is a subset of that. So machine learning is a subset of AI. So within maths, you can think of calculus as being machine learning, which is a subset of AI. Then deep learning is a subset of machine learning. So you can think of stochastic calculus, which is a subset of calculus. It's similar to deep learning. So this is basically AI and machine learning and deep learning. If you talk about like what's the definition, what's AI, what's machine learning, what's deep learning, why do we have different terms? So AI is basically a broader, big umbrella thing where we talk about the methodology or algorithms which kind of capture human behavior. They try to replicate human behavior. So for example, listening and voice recognition and these kind of things is a bigger umbrella for AI. Machine learning is a subset of AI, which is more about kind of recognizing pattern in high dimensional data and without asking machine or algorithm to do what exactly has to be done. So that's basically machine learning. And deep learning is a subset of machine learning, which is kind of how our mind behaves, where we have artificial neural network. And generally, on a very high level, any artificial neural network that has more than 3 layers is categorized as deep learning or categorized in the category of deep learning. So deep learning basically is the study of artificial neural network with more than 3 layers. So this is how we basically divide AI, machine learning, and deep learning. And it's fine to use these terms interchangeably. There's no issue as such. Then comes data science. So what is data science? So data science is something which kind of, you can think of, example I gave about maths, you can think about this as physics. So a lot of things overlaps between physics and maths. Similarly, a lot of things overlap between your data science and AI or machine learning or deep learning. But it is a study of data in all together, I mean, separately. So there are a lot of other things, for example, data mining, big data. These things might not be a part of AI or machine learning necessarily. There are a lot of common tools that data science borrows from AI and machine learning, but it's a separate field altogether with few things overlapping with AI and machine learning. And then we have all these things: supervised, unsupervised, reinforcement learning, and NLP. So I can quickly give an overview, and of course we can talk about it in more details, but basically all these are subset of machine learning. So supervised learning is a study of or kind of uh, the type of machine learning where we have labeled data set, where we say that, okay, whether the mail is a spam or not a spam, what should be the price of Apple tomorrow. So these are basically uh, studied, or this is what supervised learning is. Unsupervised learning is basically making sense of unstructured data, finding pattern in unstructured data. So there are again subset of unsupervised learning, which is like dimensionality reduction, clustering, so on and so forth. And reinforcement learning is something which is very interesting for me. And this is basically maximizing the rewards. the algorithm where you basically maximize the rewards and reduce the punishment. So for example, if there is a child and you ask that child, hey, if you get a good grade, I'll give you a bike. So child goes and figures out all the activities, all the actions he can take to maximize his grade and to get a bike. So that is what we are doing in reinforcement learning. We are asking the algorithm, we are giving them some kind of reward function that, okay, if you do maximize this reward, uh, if you perform some action to maximize this reward, that is basically how the algorithm should be designed. And that basically is reinforcement learning. And then we have NLP, again, another area which comes under AI. And there are, of course, a few things that overlaps with machine learning as well. So NLP is simple understanding of the human language by machine in very simple terms. So that's basically description of everything that
Okay,
we talk about.
great. So let's before we shoot for the stars, let's get very nimble and humble. For example, when you mail your letter to the post office, people may not realize that, but I believe there's machine learning involved in terms of reading, right, the letter. Because how does a post office know, how to mail your letter? Like, you write 508 and you mail it, and somehow it gets to the other side. And I understand that, usually people, if they don't know what it means, everything is processed in the post office, right? And they read this, and there's a machine learning component that has learned as to what a 5 is supposed to look like, and that they're able to. So that could be an application, machine learning. Now, how about Amazon, for example, these big companies? Because you talk about reward, like Netflix, and
Right.
is that used as well with these guys?
Yeah, of course. I mean, all these Apple Siri, Amazon recommendation, all these use machine learning. So they have complex machine learning, and maybe those might be deep learning. If you remember the definition of deep learning, which I mentioned, there are a lot of layers. So the artificial neural network, which is used in deep learning, is complex. And that is what generally is used in all these big tech firms for voice recognition, for image detection or image recognition, on Facebook for detecting your face. So that is basically kind of supervised learning with a complex structure in the model that is being used by all these tech companies.
And that's why I think it took off, right? Because Amazon took off that way. Netflix. I mean, they got larger and larger, and today they are the market. So obviously, you're right to write a book like that because, yeah, if you want to work for these companies, first of all, understand what's going on. They have exploded this market, really. I mean, it's huge, actually. People don't realize how much of it is used around us, right? With as you mentioned, Amazon and all those reward mechanisms. So let's get back to the book. And tell us, because you talk about some applicability of it. And let's talk about portfolio management, for example.
Sure.
So how are you using it within that context?
Yeah. So I'll give you a quick background of the portfolio management, how it has changed in the last couple of years. And there have been there was a study which was done by McKinsey. More than 40% of the investors, they switched to AI-based or robo-advisor based portfolio management, and it's going to grow going forward. We might see an asset under management of around 2 or 3 trillion in the next 2 years under all these AI-based portfolio management funds or the companies. So talking about how it is useful. So there are a couple of elements in portfolio management. First and foremost thing, it's portfolio allocation. So historically, we have been doing mean variance analysis or Markowitz frontier for all these allocation. Then there is understanding the risk appetite of the investor. So that's basically something which is key because that is in the foundation of the entire portfolio management. A portfolio manager, which will allocate the resources or the asset in the portfolio of an investor based on his or her risk appetite, right? So understanding risk appetite is really important in portfolio management. And the third one being automation or robo-advisor. So let's talk about all these 3 elements one by one. So first we talk about the allocation. So historically, as I was saying, we have Markowitz mean frontier method. And what we have seen is that it's kind of academic in the sense that if the inputs are not stable or inputs have error, then what happens is the allocation might be unstable. And that is something which can be taken care by machine learning. So if you look into the book, there are 3 different ways we have tried to resolve it. So one is using principal component analysis, which is a type of dimensionality reduction. So what we have done is there's a thing called eigen portfolio, which takes all the asset, creates different eigenvectors. I mean, I might be slightly technical, but what it basically is doing is creating orthogonal or independent set of portfolios. And you check which of the set of portfolios is making maximum amount of money, a maximum amount of Sharpe ratio, maximum risk adjusted return. So that is one way. Then there is another way, which is called hierarchical risk parity. And this is something which we derived from one of the great book in machine learning in finance from Marco Di Prado. And what it's doing is it's doing some kind of clustering analysis on all the assets which are there in the market to figure out the groups of similar assets and then allocate to the groups which are kind of similar, or sorry, allocate to the groups which are different. And in this way, we get more diversification as compared to the normal mean variance algorithm. Then we have another approach of portfolio allocation where we have used reinforcement learning. So reinforcement learning, again, I like this the most. Why? Because you just give the algorithm the reward function. So you are saying to the algorithm, hey, why don't you maximize the risk adjusted return of this portfolio? So the algorithm by itself goes and allocates the portfolio into different assets so that it maximizes the risk adjusted return or whatever is the Sharpe ratio that needs to be maximized. So there are different ways of using machine learning. I mean, these are just a couple of approaches. Of course, there are a lot of new approaches coming up, but there are few directions in which you can proceed in looking at the case studies in the book. And that is where you can find help in the portfolio allocation. That's number one. Now, then I talked about the risk appetite of the investors, right? So as of now, what happens? A portfolio manager goes to an investor, says, hey, can you fill this risk questionnaire? And depending on his state of mind, let's say the market is good or the market is bad, depending on the state of mind, an investor says, okay, I am very risk averse given that market is not doing well. This is COVID time. But that might not be his true risk appetite. And given that he or she has not started with the right risk appetite, and he has not mentioned the risk appetite to the portfolio manager, the portfolio manager might end up allocating the resources or the asset not correctly, not to maximize what the investor is looking for. So we can use machine learning or data science here and look at what good investors have been doing in the past and assign a new investor to a group of good investors where his or her characteristics are in line with what has been there in that particular group. And then you can start from there. So basically what you're doing is you are trying to get rid of behavioral bias of an investor by using this data science approach while trying to figure out the risk appetite. So that's one of the use case, and that's there in the book. Then we, of course, have robo-advisors. So robo-advisor are a pretty interesting area because what might happen due to robo-advisor, and this is just in a speculation, that in future we will see things being automated starting from finding the risk appetite to portfolio allocation to rebalancing. And machine learning and AI will play a very important role there. And there is a couple of example, and there is one case study in the book where we have shown a robo-advisor, a prototype of a robo-advisor. There's a dashboard which is powered by machine learning. And that is something which students especially, or somebody who is like building a robo-advisor from scratch, can take a look and try to understand how machine learning can be used. So these are the couple of use cases. And of course, there are a lot of other use cases. For example, risk management, even trying to figure out a trading strategy might be a part of portfolio management, but of course we can talk about that separately. But just
before you go into the risk management, I just want to say that it's not just a case study. I mean, there's a company on the West Coast that actually does that. I mean, where you could literally, with your iPhone, download the app, and it does portfolio management for you based on your risk appetite.
Right, right. Yeah, I mean, there are indeed quite a lot of robo advisors
Yeah,
which are actually doing that. And you have everything end to end. So you mentioned your goal that after 2 years, I want to travel, I want to save money for this vacation. So what they will do is they will put your asset in portfolio in such a way that your final goal is met, and everything will be done by machine learning in background. So that's again something, a hint of that is there in the book. Yeah, I mean, these are a couple of use cases or case studies that we have from the portfolio management perspective.
you're gonna talk about risk management. Go ahead.
Sure. I mean, risk management, there are a lot of use cases currently. So, for example, in counterparty credit risk or for market risk, there are times where it's very difficult to price or get the sensitivity of different trades because there are a couple of complex trades and structures, and you have to run a lot of Monte Carlo simulation by the conventional techniques, right? So that is where machine learning can be helpful. That is where you can use deep learning, and there are a couple of companies which are actually doing it. So that's one part where we can use the risk management. I'm mostly talking from the investment banking perspective, and there can be, of course, a lot of other risk management area, for example, fraud and all, which we can talk about later for the retail banking. But yeah, for the from the investment banking perspective, the main kind of risk are market risk, credit risk, counterparty credit risk, and we have seen uh, the influx of machine learning and data science in all these areas. Then we have something interesting called hedging. I don't know whether you want to call that hedging as a part of risk management, but generally, I mean, when a trader is trading, then he or she wants to kind of risk manage his or her book. And we generally, or what we have seen in the past is for the risk management, the old conventional models are being used. So, for example, Black-Scholes and all these derivative pricing models might be used to figure out that what is the sensitivity, and then on the basis of that, find out a hedge for one particular trade. But this has, or using the conventional methods, have a lot of limitations in the sense that there are a lot of assumptions there. For example, Black-Scholes model, you assume that the price is log normally distributed, there is no market friction, and there is no transaction cost, so on and so forth. So you can use machine learning there. And there is an example in the book where we have used reinforcement learning to find out the hedges. Or the way it works is you essentially, it's a kind of optimization equation where you're trying to maximize the hedge error, and you're not having a lot of assumptions which are there in the old models or the conventional model. And the machine looks into or finds out the hedge in such a way that it minimizes the hedging error, and and it takes everything, all the inputs, including like the market transaction cost, liquidity, and everything into consideration, and you get a hedge which is basically optimal, and you don't have to depend on any particular model as such. So that's basically another area where it can be used in risk management.
Now you had mentioned fraud.
Yeah.
Let's talk about fraud, especially with everything that's going on with banks. And you're probably aware that blockchain is also trying to capture that market, that fraud market as well. So
Yeah,
what
sure.
about?
Yeah, the fraud is I think one of the use case that was there since always, since a long time. So that was the one of the first few adopters, or first few areas which adopted kind of machine learning and AI. So talking about the magnitude of, or the impact of the fraud, I think the overall impact of fraud in the world is around like $5 trillion. So that is something which everybody needs to focus on. And machine learning models are kind of ideal to fraud detection. Why? Because basically what you have, the problem or the problem definition that you have is you have all the data set about the transaction, including who transacted, from where the transaction was done, which state, and all these parameters, which we call feature. And eventually what you have to do, you have to detect whether, or you have to see whether that particular thing was fraud or not. right? So it's a typical case of supervised learning or supervised classification, you can say, where the output is 0 or 1. 1 being, okay, this transaction can be a fraud, and 0 is this transaction cannot be a fraud. And there are a lot of features on which you basically decide whether it's fraud or not. So that, and in the book we have one use case of the fraud detection, where we have taken around 150 features or so, and on the basis of that we have trained a model using different kinds of classification models, not just the normal one, as in not just the logistic regression, but also trees, also ensemble, also artificial neural network based training is something that we have done, and try to figure out or try to find out the best model which can capture which has the best accuracy. Now, there are two problems or two issues that we have when it comes to fraud detection. The first is that the data set is really unbalanced. What I mean by that is that let's say you have 1,000 observation, right? And in those 1,000 observation, you will just see around like 10 or 12 fraud, and rest all will be not fraud. So it will be very difficult to kind of train a good model. A model will give you high accuracy, but it might not be able to model those fraud cases quite well. So we have somehow handled, there are a couple of approaches we have talked about in the book, how to take care of the unbalanced data set, especially in the fraud detection space. So that's number one. And the number two is a very common problem that everybody talks about when it comes to machine learning: explainability and interpretability, right? So if you are categorizing any transaction as fraud, you need to know why you have done that. And let's say if you're blindly applying artificial neural network or some high level deep learning, it might give you a good accuracy, but it might not be able to provide you the details as in what were the driving factors. And that is where you have a trade-off. There might be a model where you have high accuracy, but the explainability is less. And there might be a good model which has low accuracy, but it's simple model and the explainability is more. So that is something we have dealt in the book as well, that how to have or how to choose the right model given all these trade-offs that we have between the high accuracy of the model and then explainability and interpretability. And that is something which I think is a important thing to consider when you talk about fraud
No,
detection.
definitely. You also talk about credit default as well.
Right. Yeah, I think credit default is very similar to fraud detection. So even the problem set or the problem definition that I explained is very similar. So you have to figure out whether a loan or let's say credit card payment will be defaulted or not, 0 or 1 output on the basis of a lot of inputs. What's the age of the person who is taking the loan? What's the income? What's the wealth? And so on and so forth. So again, the problem are twofolds, same as fraud detection. Number one, the unbalanced data set, and number two being interpretability. You have to make sure that the models are kind of interpretable, or the output is interpretable, and that is something you need to take care of. And then there can be not just credit default. We also do some kind of credit scoring, where we assign some sort of credit score to the different lenders and borrowers and different people. So of course, FICO, for example, has its own methods or model to assign your score to you. But there can be, or there are a lot of advanced machine learning based approaches. So for example, not only on the basis of your income or wealth, but you can go to for example, what you are posting on your social media feed, for example. You take the information from there, and taking the input from there, you finally assign a score to a person or to an individual who has taken loan. So yeah, I mean, there are a lot of interesting things which are coming up, and there are a few glimpses of these things in the book.
So let's talk about another big one, about trading, and derivative pricing.
Okay. So trading is something I can go on and on. So yeah, I mean,
Try to
trading.
limit yourself.
Yeah. So trading, we have quite a lot of example, and as I mentioned before, there are a lot of machine learning books which are focusing on trading, right? So how to approach trading algorithm or trading strategy or algorithmic trading using machine learning. And there can be 3 or 4 different ways. I'll talk about all supervised learning, unsupervised learning, and reinforcement learning. So let's talk about supervised learning first. So what we have in supervised learning, we have a labeled output, 0 or 1, or price of Apple in future. So first, there are 2 parts of supervised learning, regression and classification. In regression, what we are doing is we are having a continuous output in the future, or continuous output. So let's say if you have a model which says that what would be the return of Apple, or what would be the price of Apple in future, that is something you can predict using regression. And a lot of time series models have been used, and somehow you can use supervised learning regression as well there. So basically what we are doing, we are saying that, hey, what would be the price of Apple tomorrow? And depending on what would be the price we get from our model, we go long, we buy or sell Apple stock, right? So that's basically regression, where you're getting the exact return or the price of a stock or any asset in future, and basis of which you are doing the algorithmic trading. Then we have classification. In classification, the output is either 0 or 1, or it's basically binary. So the way we formulate the problem statement is whether the stock price will go up or down, right? So depending on different parameters or different factors, we create a model which predicts whether the price will go up or down. If the model says that, okay, the price tomorrow will go up, then we go long or we buy, or and if it is goes down, or if it shows 0, then we kind of short, or we sell that particular stock, or we sell that particular asset. And while doing that, you can have all these features as an input to predict. So we have a lot of things like momentum indicator and volume based stuff, order flow. You can use all these things to predict whether the price will go up or down, or what would the price of Apple in future. So that's basically the supervised learning approach. Then we have unsupervised, and all these examples are there in the book. I forget not to kind of advertise my book. So yeah, I mean, these 2 examples are there in the book. Then we come to the unsupervised learning, and then unsupervised learning has 2 elements, or there are 2 things basically on a high level. One is dimensionality reduction, and then we have clustering. The way dimensionality reduction is used is, in finance generally we have big data set, and there are a lot of features, a lot of parameters. So we use dimensionality reduction to kind of reduce the dimension, and then feed to the trading algorithm and say, hey, you had 50 different dimensions before, now you have just 3 or 4 different dimensions, and that is what you can use to predict the price in future. Then we have clustering, and there is one example of how we can use clustering for trading in the book. So there is example of pairs trading. So what we basically do in pairs trading, we try to figure out what are the pairs which we can use for trading. So pairs trading is basically you go long on one stock or one asset, and go short on one asset, and then buy one and sell other. And you have to find out 2 assets which are kind of correlated. And then to finding out these 2 assets, you have to spend quite a significant amount of time, because there are numerous and lot of assets, and then you have to figure out, or get like 2 or 3 assets on which you can apply pairs trading. So clustering makes things easier, because you can group similar assets or similar stocks together, and then you can say, hey, I will basically find my pairs from this particular group which has been created by the clustering. So there is an example again in the book. So that was second part, that was unsupervised learning. Now let's go to the reinforcement learning. And this is the most interesting bit, because the example that I gave before, that you're asking a child to get a grade A, and you assign a reward to that child saying that, hey, if you get grade A, you will get a bike, right? So similar thing you do to the algorithm. If you are able to maximize your risk adjusted return of this particular portfolio risk or particular trade, do whatever you want to do there, but you have to maximize this risk adjusted return, or let's say Sharp, and the algorithm trains itself in such a way that it maximizes the risk adjusted return or Sharp. and you can use it like a trading bot, right? So that is where the reinforcement learning, and it's very good because you don't have to do all these kind of training. You don't have to understand what are the features and everything. Of course, there can be drawbacks to this, but the advantage is that you don't have to decide the policy. You don't have to decide what has to be done. You just give the reward, and machine trains all by itself. And there, of course, there is one example in the book or case study in the book for that. That's basically reinforcement learning. And then we also have NLP, natural language processing.
I was going to ask you
Sentiment,
about that.
yeah, sentiment analysis, which is something uh, quite used quite a lot on Wall Street these days. So what's basically happening there is it's more related to AI, and AI algorithm reads, let's say, Twitter feeds or news, and it using its trained algorithm, it says that, okay, this particular news has a positive sentiment, meaning that on a scale of 10, I get, or the algorithm says that I have sentiment as like 9 out of 10, meaning that it's positive sentiments. Now, given that it's a positive sentiments, let's go and buy the stock, or let's go and buy the asset. This is how it works. You have news or Twitter feeds, algorithm understands that, okay, this, what's the sentiment of this? There's a trained model, of course, and depending on that, you buy or sell or do whatever you want to. And that's basically the sentiment analysis. And yes, we have an example of sentiment analysis as well in the book. So yeah, I think I've covered everything related to trading.
Yes. Now, what's going to happen with quantum computing? How is that going to impact, machine learning, and are we just going to go faster? Is that all there is, or do you think that has it hit the market yet, or is it still just something out there yet?
Yeah, to be frank, I might not be very much knowledgeable about it, but as you summarized quite well, I think it will make things faster. So when you are using machine learning, one of the argument that people say, or one of the drawback people talk about, that machine learning models can be slow. So one of the solution that we have as of now is GPU. So okay, let's use GPU, and which is faster, multiprocessing. Going
Mm-hmm.
forward with this cloud computing, my understanding is it might be even faster. So when you're training a model, for example, training a pricing model, you can train it pretty quickly. Or let's say you are running overnight batches of all the pricers in your in let's say bank. Using cloud computing, it might be much faster. So essentially, it might accelerate the adoption of machine learning and data science in future, because that will take care of one of the drawback, which is that all these machine learning and data science algorithms are slow to train. If that is solved, of course, the adoption will kind of increase going forward.
Great.
That's my take. I mean, of
Oh,
course,
well,
I
we'll
might.
see. We'll have you back to talk about it although it's moving faster than I thought. We have a couple of people at the university that are actually working on that already. In terms of the advance, because it's going to change a lot of the optimization methods, and everything is going to go. I mean, it's not for everything, believe it or not. You can't apply a quantum computer to everything.
Yeah.
But I mean, so I think this is, thank you very much for your time. I mean, this is quite an interesting book, I have to say.
Mm-hmm.
The student definitely should, and even practitioners really, were not familiar with it. And they need to become familiar with machine learning and all the caveats around it, because, it's all about data.
Absolutely. I mean, there is going to be some kind of paradigm shift, I feel, at some point of time in future, and people will start adopting machine learning. Because if you think, the wave is already there. So we already have a lot of data coming. We already have faster computer. We already have adoption even in the conventional financial stuff. So for example, all these pricing and hedging, which was done using conventional models. Now slowly there are a couple of papers which are coming up, which are adopting machine learning. And if you talk about jobs, so people say that, hey, the jobs will be gone in future. But if you think about the reason, why the jobs will be going, because the jobs are getting automated. Why are jobs getting automated? Because there is adoption of AI. And what is AI? It's basically artificial intelligence and machine learning. So more and more people related to artificial intelligence and machine learning will be able to find jobs, because jobs in these areas will grow going forward. And that's why people, I think at this point of time, and that's my perspective, they need to reinvent themselves and need to understand machine learning and data science to keep themselves uh, kind of alive, or keep alive in the market, or keep themselves ready for whatever things are going to happen in future. So I feel it's something which is necessary, especially for the quants, especially for the students who are currently studying masters in financial engineering, or even let's say data science, who are interested in finance. So knowing about the use cases of machine learning and data science, I feel, is really important. And
Yeah, especially with the Python and its libraries. I mean, it's coding has become so much easier now that it should be the Excel of the future. Quite frankly, I mean, that's people should start looking at it as it's not science fiction. It's
absolutely.
acceptable to you. It's gonna yeah, you're gonna have to familiarize yourself a lot more. So, and I think your book is it's a great way to start that. So I wanted to thank you, Hariom, for your time.
Mhm.
Um, Maybe you could come back at some point where very specific, I'm thinking maybe some specific cases
Right.
from the
I
book. I think it'd be a lot easier to grasp right?
Yeah, maybe. I mean, I feel that whatever I have spoken, it might be slightly on a high level, in the sense that it requires a little bit of understanding. So, for example, few terms like
Yeah,
Markovitch,
of course.
mean variance analysis, and all. It might require some more understanding, but I think I've tried to cover things
No, I think so.
as 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 as
Lots
as
of topics. I mean, we talk about portfolio management, for detection, credit trading, derivative pricing. People have to realize that it's not just a bunch of scientists working in it's
Absolutely.
used. It's used
Yeah.
every day when you click on a movie and you see you like it. Boom! It takes and it advises you on what to do, and robo advising. I mean, I don't know if they're going to take over some of the large firms in New York in terms of for management, but it's growing.
Yeah.
It's a lot more accessible.
Definitely.
It's
I mean, the people talk about okay, machine learning is not interpretable. It's very complex. I not really agree to that. I mean, of course, we can talk about that in another session, but
yeah,
that
sure.
is one of the point I wanted to highlight as well. That it might be complex, slightly complex, but it might be difficult to interpret in some cases. But if you think about it, you are deriving all the information from data, and which is very powerful. You don't have any functional form like an equation that we used to have in conventional finance. So that is where the power of machine learning lies, and I think the future is going to be bright.
Great. Thank you very much.
Thanks,
And
Patrick.
you definitely have to come back for another session. I mean, now you piqued my interest. I'm sure piqued a lot of interest from other people. So
Sure.
hopefully the book does well, and it's available on Amazon. So and I'll put a link on my the
Sure.
caption. Thanks.